Welcome to this HP Technical Configuration Guide. In this TCG, we're discussing multiple spanning tree with an emphasis on interoperability between HP Comware switches and Cisco switches. We'll be looking at the configuration steps for configuring both Cisco and HP Comware switches in a single STP region. So firstly, let's look at the topology using the defaults. By default, Comware switches do not run multiple spanning tree. I've connected the switches to HP's Intelligent Management Center, or IMC, management application. And in the topology view, I have selected the CIST instance. So this is actually showing us dynamically which ports are forwarding and blocking and where spanning tree is enabled. So in this case, notice both Comware switches don't have spanning tree enabled, but the two Cisco switches have spanning tree enabled. The blocking port on Cisco 1 is port gigabit 103. The blocking port on Cisco 2 is gigabit 102. So IMC is showing us in real time which devices have spanning tree enabled and which ports are blocking. To see that in the CLI, I'll connect to Comware 1. So on Comware 1, display STP. Notice spanning tree is disabled. On Comware 2, display STP. Spanning tree is also disabled on Comware 2. What about Cisco 1? Show spanning tree. Notice the protocol listed is IEEE. However, if we look at the summary, so show spanning tree summary, notice the protocol in use is PVST. On Cisco 2, show spanning tree. Protocol listed is IEEE. Looking at the summary, notice PVST is the mode used. Back on Cisco 1, show spanning tree. Notice port gigabit 101 is forwarding. Going to IMC, gigabit 101 is forwarding. Gigabit 102 is also forwarding. Gigabit 103 is blocking. So on IMC, notice we can see that gigabit 103 on Cisco 1 is blocking, but gigabit 102 is forwarding. So IMC is showing us visually the output of spanning tree, as confirmed by using the show commands in the CLI. On Cisco 2, show spanning tree. Notice gigabit 101 is forwarding, gigabit 102 is blocking. So, Cisco 2, gigabit 101 is forwarding. Cisco 2, gigabit 102 is blocking. Once again, IMC is showing us visually which ports are forwarding and blocking. The reason why these two ports in Cisco are blocking is there's a loop over here, as well as a loop over here. The Comware switches are not running spanning tree, so the Cisco switches are sending BPDUs and receiving those BPDUs from each other, with the Comware switches being transparent in this topology. So the Cisco switches are blocking ports to stop loops. The Comware switches are just transparently forwarding BPDUs. So now let's configure multiple spanning tree in this topology. So the first step is to configure a multiple spanning tree on the Cisco switches, but not change the mode to multiple spanning tree. The Cisco switches will still be using PVST, but the configuration for multiple spanning tree would have been done. So I'll paste the configuration on the first Cisco switch. Notice please, show spanning tree MST configuration shows that the switch is not currently in MST mode. We have changed the region name, revision number, instances, and VLAN mappings to instances, as you can see in the output here. Notice, for example, that VLANs 2 and 4 are mapped to instance 2, but the switch is currently still running PVST. Show spanning tree summary shows that the mode is still PVST. On Cisco 2, show spanning tree MST configuration, shows us that the switch is not in MST mode. Once again, show spanning tree summary, shows that the switch is still in PVST mode. So the two Cisco switches have been configured with MST configuration, but the configuration is not active at the moment. Show spanning tree MST configuration shows us the region configuration, but the two Cisco switches are still running PVST and the HP switches are not running spanning tree at the moment. The next step is to configure the first Cisco core switch with spanning tree instance priorities. So for instance 2, the switch will have a priority of 0. In other words, it will become the root. For instance 0 and instance 1, the priority will be 4096, so it will become the backup root. We want to load share traffic between the two core switches. So Cisco 1 will be the root for some VLANs based on instance 2, and the backup root for other VLANs based on instance 0 and instance 1. So on Cisco 1, the priorities for instance 0, instance 1, and instance 2 have been changed. Cisco 1 should become the root for instance 2, and when Comware has spanning tree enabled, Comware 1 should be the root for instance 0 and instance 1. On the HP switches, we're going to configure multiple spanning tree, but not enable spanning tree at this point. So spanning tree is still not enabled on the HP switches, but the multiple spanning tree configuration is done. And then we're changing the path costs to use industry standard costs and changing the BPDUs on the interfaces to use industry standard BPDUs. The priorities of the instances on the core HP switch are also changed. So the core HP switch will be the root for instance 0 and 1. Notice the priorities are set to 0, but the priority for instance 2 is set to 4096, so it will be the backup root for instance 2. So on HP 1, scrolling up, we can view the configuration. So the region configuration has been set. Region name HP, revision level 1, VLANs 1, 3, and 5 are mapped to instance 1, VLANs 2 and 4 are mapped to instance 2. We can check the configuration. So that's the configuration that's been set. The configuration has been activated, but spanning tree has not been activated at this point. Industry standard cost values have been configured, as well as compliant BPDUs. However, display STP shows that spanning tree is still disabled on the switch. On Comware 2, paste the configuration. The configuration is the same. Name of region, revision level, instances, and VLANs mapped to instances are the same. The region has been activated. Industry standard path costs and compliant BPDUs have been configured, but once again, display STP shows that spanning tree is disabled on the switch. To change the priority values of Comware 1, paste in the configuration. Comware 1 is going to be the root for instance 0 and instance 1, and the backup root for instance 2. The last step is to enable spanning tree on HP and configure the Cisco switches to use multiple spanning tree. We need to do this on the core devices first and then on the edge devices. To minimize downtime, I've got the commands ready on the consoles of each switch. Spanning tree will need to do a recalculation. Interfaces will go up and down. So to minimize the time that spanning tree takes to recalculate, I've got the commands ready on each device, and I just need to hit enter to execute the command. So on Comware 1, STP enable. Cisco 1, spanning tree mode MST. Comware 2, STP enable. On Cisco 2, spanning tree mode MST. The configuration needs to be enabled firstly on the core devices and then on the edge devices. The switches are recalculating. As you can see here, VLAN interfaces have come up on Cisco 1, once again indicating that there's a topology change. Spanning tree is recalculated. Layer 3 interfaces would go down and then come up on Cisco devices when the spanning tree mode is changed. So try and minimize downtime as much as possible by having the commands ready in the consoles of the devices. So within IMC, I'll exit the multiple spanning tree view. I'll synchronize the topology on each device. IMC will log into the switches and update the topology view. So, going back to the spanning tree option, let's look at the CIST. We can see which ports are blocking. Now, based on our configuration, Comware 1 should be the root for the CIST. So right-click on the Comware device, look at spanning tree information. We can see the master bridge information. Master path cost is 0. The local switch is the root for spanning tree. Notice for the instances, for instance 0, 1, and 2, we can see the priority of the switch. We can see the root path cost. So this switch has a root path cost of 0 to get to the root. This switch is the root for the CIST. IMC shows graphically which ports are being blocked. So with Comware 1 being the root of the topology, it's correct that these ports on the access switches are blocked. So on Comware 2 as an example, clicking on the link, we can see that gigabit 102 is blocking on Comware 2, which is correct. To see that on the CLI, display STP on Comware 1. Notice on Comware 1, the CIST bridge ID ends in 85DF, and that's the common instance spanning tree root. Notice the external root path cost, which is the external cost out of this region to get to the root, is 0. The local switch is the CIST root. For the regional route, the MAC address is the same. This is the cost within the region to get to the regional route, also 0. So Comware 1 is the root for the CIST. On Comware 2, display STP. We can see that 101 is forwarding as per the IMC diagram, and this is the root port. Going to port 2, notice port 2 is discarding, it's the CIST alternate port. On Cisco 2, show spanning tree. Notice the blocking port is gigabit 101, which is this port on the switch. By clicking on the port, we can see that information. Notice gigabit 101 is blocking. So IMC is visually displaying blocking ports in our topology. In this video, we looked at the configuration steps for configuring multiple spanning tree on both Comware and Cisco switches. The devices were configured in a single region with the name HP. Comware 1 was configured as the root for instance 0 and instance 1. Cisco 1 was configured as the root for instance 2. Instance 1 had VLANs 1, 3, and 5 mapped to it, and instance 2 had VLANs 2 and 4 mapped to it. All remaining VLANs not explicitly mapped to other instances, are implicitly mapped to instance 0. We then used show commands to confirm that the switches were configured in a single region and that load sharing was taking place on the uplinks from the edge to the core. That concludes this video discussing the configuration of multiple spanning tree on HP, Comware switches and Cisco switches.